Thank you for joining me. In this video, I'll be talking through all of the answers to our Expo Chapter 7 practice test or pretest. So after working through it on your own, if you have any questions, you can use this video to help clarify any of the answers that you get. So if you notice, our first section is a matching section, okay? And I want you to pay careful attention to our second sentence here. Some answers can be used more than once or not at all. Okay, that's going to be really, really critical to make sure you're not taking away answers and then not recognizing you could potentially using them again, or the fact that not every answer is going to be used. So let's dive right into number one. Number one, the first thing that I notice is that negative exponent. Okay, so to remove that negative exponent, I'm going to move it down to the bottom. Remember the analogy I used in class, a negative exponent is like a negative attitude. You need to make it move so it can get a better attitude, okay? So I move it down, so the exponent is now positive, and now 1 over 3 squared, well 3 squared we know is 1 over 9. So let's look to see which answer that matches. And it looks like that's going to match letter D, 1/9. Number two, this is our power of a power rule. Okay, power for power, that is when we end up multiplying our exponents together. So we're going to end up with 3 to the 5 times 4 or 3 to the 20. So looking down at our answer bank, that would be option B. Number three, 3 to the 6 divided by 3 squared. Well, this is going to be our subtraction rule. When you're dividing two things of like base, we end up subtracting our exponents. So 6 minus 2 leaves me with 4. And 3 to the 4 matches letter F. Now notice here, remember, my base doesn't change, only the exponent changes, okay? So don't go changing the 3 at all. The 3 stays. It's only the exponent that ends up changing. Number 4, 3 to the 7 to the 0. So here what I notice is that 0 exponent. That was the very first thing that we talked about. And remember, when you have an entire parenthesis being taken to the 0 exponent, the whole thing simply becomes 1, okay? That's the power of a 0 exponent automatically is going to become 1, which is going to be letter A. Number 5. So number 5 is kind of a curveball, okay? Because there are no rules when it comes to adding things of like bases, okay? So for this one, really the only option that you have is calculating both of those numbers separately. So for example, 3 squared is simply the number 9. 3 to the 4, maybe you don't know it at the top of your head, but you're welcome to use your calculator. 3 to the 4th is 81. So when you add them together, that gives you 90, or letter E. But the thing to remember is there's no rule per se to solving that one. You legitimately just have to calculate both numbers and then simply add them together. 6 looks an awful lot like number 3, okay? We're dividing things of like base, meaning we're going to be subtracting our exponents. Well, 2 minus 6 leaves me with a negative 4 exponent, okay? Now this takes us back to the whole negative exponent deal. Remember, negative attitude, you want those people to get away from you. So you're going to move that negative exponent to try to help it get a better attitude. So I'm going to move that whole thing down because in the bottom, it can have a positive exponent. And now that matches letter H. Number 7, 3 squared times 3 to the 4. So here we're multiplying things of like base, okay? And when you're multiplying things of like base, you end up adding your exponents together, all right? And that's going to end up giving you 3 to the 6th or letter C. Now this is a thing you have to make sure you remember the difference between that and the power of a power rule. So how I kind of think of it is if I see both things separately like this, I think of having 2 over here, 4 over there for a total of 6, okay? So when they're written separately, implying that you're just multiplying them together, think of them just, oh, okay, I have 2 here, I have 4 here, that's going to give me a total of 6, okay? Which is different than one like number 8. Okay, number 8, I don't see them written separately. I don't see separate 3s happening. It's just 1 3 with a power of a power. So that's why number 8 is different, okay? Power of a power takes us back to multiplying the exponents together, and that is going to leave us with letter I. All right, so that's just a practice of making sure that you can tell the difference between all of these rules in a multiple choice setting, or I should say in a matching setting. Okay, so after that, now we dive into the normal ones where we like to see your work and you're just answering them like you did in the homework. So use the properties above to simplify each expression completely. Do not leave any negative exponents and write all non-variable bases as a single number. So for example, like I did in every homework and every note, I don't want to see 5 squared. You would just write that as 25, all right? So let's start running through this page. And I'm sorry, I scrolled down a little bit too far. There we go. All right, x to the 7 times x to the 4, okay? Multiplying like bases means we are going to add the exponents together, okay? Or again, think of this as I have 7 over here, 4 over there, so all together I have 11 because they were written separately, okay? And then of course you do want to write your answer over here in the answer bank. Number 10. The striking feature number 10 that I noticed is the negative exponent, okay? So again, negative exponent is like a negative attitude, move it away. I'm going to move it to the bottom where it can have a positive exponent. Then of course, anything to the first power is just itself. So to write this a little bit cleaner, I could just write that as 1/5. Number 11, again, notice the difference between number 9 and number 11. Okay, number 11 is a power of a power. M to the 3 to the 4th power. Power of a power is where you end up multiplying those exponents together to get m to the 12. So again, make sure you know the difference between 9 and 11, okay? That's going to be critical throughout this test to make sure you understand that. Number 12. So number 12 is one of the 0 exponent ones, okay? Now the striking thing about this, okay, is notice there's no parentheses here. So that negative is not connected to the 0 exponent, okay? The negative is off on its own. So the negative is going to stay in my answer, and then 9 to the 0, that is what is going to become 1, okay? So make sure you understand that difference of when the negative is not grouped with it because of a parenthesis, the negative is going to stay in your answer. Number 13. So in number 13, we have a whole parenthesis being taken to a power. 4 and x both being squared. So that squared is going to apply to both pieces, okay? I end up with 4 squared, which is going to give me 16, and then x squared. So make sure that you remember, apply any power throughout the entire parenthesis, okay? 14, we're practicing our division rule, okay? M to the 7 divided by m to the 3. Well, remember, with dividing like bases, we end up subtracting our exponents, and that is just going to leave us with an m to the 4. Number 15, I see a negative exponent being taken for a fraction, okay? So remember, to alleviate that negative exponent, when you have a fraction, all you need to do is flip the fraction, okay? Take the reciprocal of the fraction to resolve that negative exponent, okay? Now that I've done that, now that power applies to both pieces. We end up with b to the 3 divided by a to the 3. Number 16. Again, I see multiplying like bases, so I'm going to be adding the exponents together. Again, think of I have -5 over here, 3 over here. Well, how many total does that mean? Well, that means I have -2. Well, negative exponent, okay? Remember, we don't want to leave anything with a negative exponent here. So what I'm going to do is I'm going to move it to the bottom. Okay, remember, negative exponent is like a negative attitude. You want to move it away from you. So you end up with 1 over y squared. Number 17. So 17, I have a whole product, an entire parenthesis being taken to a power. So I'm going to apply that power to everything inside that parenthesis. So the first thing is -3 squared. So -3 times -3. Then it's going to end up being a positive 9. X cubed squared. So x to the 3 to the 2, that's an example of a power rule. And remember, power of a power, you end up multiplying your exponents to give you 6. And then y squared, well, the square just attaches onto the y because it didn't have any power to begin with. And that is going to be our final answer for that one. 18. Number 18, I see that entire parenthesis being taken to the 0 exponent, okay? The whole thing. So because that whole parenthesis is being taken to the 0 exponent, the whole thing is simply going to become 1. Okay, it looks like a scary problem, but it's one of the easiest. Just done. Number 19, 5x to the -2. So here we have to be careful, okay? So we only want to move the piece with the negative exponent, okay? And here the 5 doesn't have a negative exponent. So the 5 is actually just fine as is. We don't need to move it, okay? The only thing we need to move is that x squared to the bottom so it can finally have a positive exponent. Number 20. So number 20, again, we're just multiplying like bases. So first, I'm going to deal with the numbers. So 3 and 5 are just normal numbers, okay? So normal numbers in this case will multiply just like they always would. So 3 times 5 gives me 15. For the exponents, though, remember, this is where you add the exponents, okay? I have c to the 4 over here, c to the 3 over here, and that's going to end up giving me a 3 to the 7 in total. Remember, multiplying like bases, you add exponents together. Number 21, I have a whole parenthesis being taken to an exponent, so I need to apply the exponent throughout. So -2 cubed. So think -2 times -2 times -2. All right, that is going to give me a -8. Okay, -2 times -2 is +4, times another -2 brings it back to a -8. G to the 4 to the 3, power of a power. I'm going to multiply my exponents. Then h to the 3 is just going to attach on. Number 22 is very similar to number 20, okay? So for number 22, again, you're just going to multiply your normal numbers to get a -24. Then for the x's, I have x to the 4 times x to the 6. So I have 4 over here, 6 over here. That is going to give me a total of 10. Number 23, I have a fraction to a power. So I'm going to apply that power throughout the entire fraction. All right, so 3 squared gives me 9, then d squared. 5 squared gives me 25, and then c squared. And that's going to be the final answer for that one. All you have to do is apply the power. So moving on to the next page. So 24 is again strikingly similar to number 20 and 22. If you want to kind of mark that down, that they have similar strategies. Multiply your normal numbers. So 6 times 3 gives me 18. N squared times n to the 8. I have 2 over here, 8 over here, so that's going to give me a total of 10 of them. All right, number 25. So 25 is just kind of a mess, okay? So this one, there's multiple things you can do to solve this one. The thing that I would do is I would kind of clean up the inside of the parenthesis first, okay? Think order of operations. So inside the parenthesis, let's clean it up, all right? So inside that parenthesis, I have a -3 and a 4, which don't simplify at all. X to the first divided by x to the fifth. So 1 minus 5 gives me an x to the -4. Okay, so x to the -4. But because I know it's negative right away, okay, what I could do instead is I could just put it straight on the bottom, okay? So note that is acceptable. And if you think about it, it's wherever there were more of them. There were more x's on the bottom, so that's where it's going to end up, okay? So either way you think of it is absolutely just fine. Now, in terms of the y's, we have -2 minus 4 for our division. Remember, division, we end up subtracting. So -2 minus 4 is a y to the -6. But again, a negative, you know right away, that's going to end up on the bottom. All right, so I'm just going to put it right there on the bottom as is. Okay, so now we have that. So now that we have the inside all cleaned up, now let's look at that negative exponent, okay? The whole parentheses being taken to a -1 exponent. So remember, when you have a fraction and it's being taken to a negative power, remember what that does is it flips everything, okay? So that 4x to the 4y to the 6 is going to end up on top, and that -3 is going to end up on the bottom. Okay, and that resolves the negative exponent, so now it has a power of 1. Well, as you know, you don't even have to show that, so I'm not even going to worry about that, okay? A first power doesn't ever change anything, okay? But that's going to be your final answer for that one. And again, the strategy, if you want to kind of make a little note in the margin, clean up the inside of the parenthesis first, then deal with the negative exponent on the outside of it. Number 26. So number 26, again, the thing that I noticed is the negative exponent, okay? So what that means is I'm going to move that whole thing down. Okay, so negative exponent, move it to the bottom, so now it is a positive exponent. -3 squared, so -3 times -3 is going to end up as a positive 9. And number 25, just because my marker is so big, I'm not going to write it in the answer bank, but do notice you would want to put the answer to 25 there, okay? It would just get really messy for me because my markers for the smartboard are kind of big. All right, so 27. For 27, my strategy would be, because you have multiple negative exponents happening here, and honestly, subtracting negative stuff like that, they can get a little bit messy, okay? So for our sake, what I'm going to do is I'm actually going to reverse them right away. So I have 2a to the 4b, ab to the 5, and then that c to the negative 1 is going to move to the bottom to become a positive exponent, and the c to the negative 3 is going to move to the top to get a positive exponent. So I'm going to move them right away to alleviate some of those negatives to make my arithmetic easier now as I move into solving the rest of it. So nothing cancels the 2, so the 2 gets to stay. For the a's, a to the 4 divided by a to the 1. 4 minus 1 gives me an a to the 3. B to the 1 divided by b to the 5. 1 minus 5 gives me a negative 4. And remember right away, that tells me it's going to be a b to the 4 on the bottom. That's where there were more of them, so that's where it's going to end up. Then c to the 3 divided by c to the 1. 3 minus 1 leaves me with 2. And that's going to be my final answer for that one. And again, I think it's easier in this case, so you don't have to be subtracting negatives and all that nonsense. Just clean it up a little bit first to make it easier to deal with later, okay? And again, my answer would be clunky to write over there, but you would want to put your answer in that answer bank for me. All right, 28. So for 28, I notice this negative exponent right here, okay? So what I'm going to do, that negative 3x doesn't get affected at all, but that 2xy cubed, because of that negative exponent, that whole thing is going to end up on the bottom, okay? So I'm just going to shift it to the bottom right away. And now I see I have x over x. And remember, x over x, if you have the same thing top and bottom, it's just going to slash off, and you're going to end up with that. The x's are just going to be gone. Number 29, negative exponent. Okay, so I have a fraction with a negative exponent. So remember, all that means is I flip that. Okay, you take the reciprocal of the fraction. Well, now the first power, well, that doesn't actually do anything. So I'm just going to leave it like that. Okay, 5/2. Number 30. So I have an entire parenthesis we take into an exponent. So remember, I'm going to apply that exponent to everything. 4 squared gives me 16. Then m squared, n squared. It just attaches itself on to both of the variables. And number 31. So 31 and 27 to me are very similar, okay? And I'm going to take a similar approach to dealing with them, okay? So I have 5x cubed and 15x to the 5. And I'm going to send that y to the negative 3 up to get a positive exponent, and the y to the negative 2 down to get a positive exponent. I'm going to alleviate those negatives to make my arithmetic easier, so I'm not subtracting negatives mid-problem, okay? 5 over 15. This time you actually have numbers that reduce. Both 5 and 15 are divisible by 5, so that's going to reduce to 1 over 3. X to the 3 divided by x to the 5. Well, 3 minus 5 is a negative 2, so it's going to be a positive exponent on the bottom. Y to the 3 divided by y to the 2. 3 minus 2 gives me a y to the 1. And then, of course, those 1s you don't have to show, so you could just write your answer like that, and then copy it into the answer bank. All right, so there are all of the rules of exponents that we discussed throughout sections 1 through 5. Okay, now numbers 32 and 33. These investigate, they want you to decide what's done wrong. Okay, I'm presenting you two problems that were solved incorrectly, and we want to discuss what was done wrong. So number 32, if you look at that one, 3x to the negative 2, okay, and they're saying it's 1 over 3x squared. So if you want, you can flag this as similar to number 19, okay? So if you need a reference point on what to do correctly, look at number 19, okay? And notice that in number 19, we didn't move the number, okay? That 3 is not connected to a negative exponent. That 3 is actually just fine as is. Only the thing with a negative exponent has to move, okay? So what was done wrong is they moved the 3 down. 2, okay? So just brief description, what was done wrong, and then you want to show me what is the correct answer. How would you properly solve this? Okay. Number 33. Well, number 33 is similar to number 12. If you want to mark that down as a reference point, okay? So remember that negative is outside the parentheses. So the negative would not be affected by the 0 exponent. Now, everything else within the parenthesis has that 0 exponent, so it all turns to 1. Okay, so what was done incorrectly? The negative is outside the parentheses, so it is in the answer. All right. So you will have two questions. You just have to discuss the errors made and then give me the correct answer. Scientific notation. All right, so scientific notation. Here, what we want to do, if remember, I always taught you put the decimal after the first significant digit that you see. So in this case, I'm going to want 4.23, okay? What I need to do now is determine what is the power of the 10. So remember, scientific notation is times 10 to some power. Well, let's find out what that power is. So I need to figure out how many times did I move that decimal. So I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9. I moved it 10 spots. So it's going to get a power of 10. Letter B is very similar, okay? Put your decimal after the first significant digit that you see. And now I need to figure out how many times do I move my decimal. So I move it 1, 2, 3, 4. But this time I started as a very, very tiny number. So I don't want 4, I want negative 4 because the number I was dealing with was extremely small. Letter C. So here I'm taking the scientific notation to a power. Okay, so this power affects both pieces. Okay, just like when we were dealing with normal exponents. So 2 squared is going to give me 4. 10 to the 5 squared, power of a power, 5 times 2 is going to give me 10. Okay, so use your normal rules of exponents there. Just make sure you remember how to apply them to scientific notation. All right, last page. So, writing things in standard form. All right, so standard form, we're looking at 2.15 times 10 to the 5 means I'm going to shift this over 5 times. 1, 2, 3, 4, 5. Notice, because the exponent was positive, I shifted it in the positive direction, if you're thinking of a number line. All right? And then I just want to write my answer nicely over here. Using the proper commas helps grading it because it shows the place values neater when you're putting your final answer. Okay? Now this one, 7.085. Now because the exponent is negative this time, it means I'm shifting my decimal towards the negative side, okay? 1, 2, 3, 4, 5, 6, 7. Then of course you fill in with all of the zeros. And then write your answer cleanly over here. So positive exponent moves it in the positive direction of a number line. Negative exponent moves it in the negative direction of a number line. All right. Bumway is a country with 6.4 times 10 to the 6 million, or 10 to the 6 people. Estonia is a country with 3 times as many people. Express the number of people living in Estonia as a number in proper scientific notation. So 3 times as many people. So I'm going to take 3 times that. Okay? And remember, when you're doing scientific notation, remember, this number, if you're just multiplying a number in, only affects the first regular number. Okay? So this is going to give me 19.2, and it does not affect the exponent, okay? Very important you remember that. Does not change the exponent. All right, so now I have it written out. However, this is not proper scientific notation, okay? And the reason I say that is right now I don't have a number between 1 and 10. So remember, we need to shift this, okay? So I'm going to shift that over. So I have 1.92. So the number I started with was too big, okay? Being too big means it has the ability to donate a piece of itself. It has excess, it can donate to the 10. So in that shift, I'm going to get my power of 10 to increase by 1 because I moved the decimal over once. Right, a square has a side length of 5x to the 6 feet. First, it wants me to sketch a picture. Okay, so square will look like that, okay? So first of all, there's just the sketch that I need, okay? And now it wants the area. So area, there's 2 ways you can find the area, okay? You can think length times width. 5 times 5 is 25. X to the 6 times x to the 6, 6 over here, 6 over there will give me x to the 12. Or, remember a square, if you know the side length, you can just square it. Okay, so you end up getting the same thing though. 5 squared is 25. X to the 6 squared, power of a power, you multiply to, oh, not 16, I'm sorry. X to the 12. So in that one, the cool thing is it doesn't matter which way you end up solving it, okay? It's going to work either way. All right, then here at the very end, we give you the opportunity for a bonus problem for extra credit, okay? So let's take a look at how we can solve this, okay? Because on the test, you'll have a similar thing that you can do for extra credit for me. So let's talk through this. Well, first, I see a lot of powers and stuff going on. So the first thing I'm going to do is I'm going to simplify the inside of my parenthesis, okay? So -1 squared, okay? -1 squared is just going to be +1, okay? And when you're multiplying, 1 doesn't even matter, so I'm not even going to bother showing that, okay? 6 to the -1, okay? That has a negative exponent, so I'm going to move that up, just like that, to get a positive exponent. Right, -x cubed, well, -x cubed, so -x times -x times -x, that negative is going to stay, so I'm just going to toss it out front, and I'll have an x cubed. All right, and then the one on the bottom, -x to the 5, -x times -x times -x times -x times -x, again, that negative is going to stay. And now for the y's, y to the -4 has a negative exponent, so it's going to get a positive exponent down below. Y to the -9 has a negative exponent, so it's going to get a positive exponent up above. All right, so that's going to be my first step in simplifying this, okay? Now, let's keep going. Negative divided by a negative, I'm just going to scratch off those negatives right there, okay? Because negative divided by negative, you know, cancels off. So I have my 6. X to the 3 divided by x to the 5. 3 minus 5 is a -2, or it would be positive down below. Y to the 9 divided by y to the 4. 9 minus 4 leaves me with 5. All right, so now let's deal with that negative exponent that's applying to the whole parenthesis, okay? So that is going to flip everything. So I'm going to have an x squared on top, and that's 6y to the 5 on the bottom. When I'm multiplying a number in, so I still have that -3 out front. When I'm just multiplying a number in, that's going to end up on the top of my fraction. And now -3 divided by 6, 3/6 reduces to -1 over 2, or -1/2. And that would be your final answer, okay? So again, this is a bonus question, all right? That is if you want to attempt some extra credit, you can do that final problem for me. So thank you for watching through this video. I hope I helped clarify any questions. If you still need any help before the test, please make sure to kind of highlight them on this sheet so you can email me or your teacher or talk to one of us in class.